All right, Mr. Ahmed here for 4.3. Goal for today is to write equations of parallel and perpendicular lines. So a couple key definitions first. You've probably heard these terms before, but parallel lines are lines that have the same slope and they never intersect. So they never touch one another. The reason why they never touch each other is because they have the same slope. Since they're rising at the same rate at different spots, they're never going to switch their steepness enough to cross, okay? Perpendicular lines have slopes that are opposite reciprocals. Now, I'll talk about what an opposite reciprocal is here in just a second, but we also want to point out that they intersect to form 90-degree angles. So it's a 90-degree angle. 90-degree angle is marked with a box in the corner. Now, what we mean by opposite reciprocals is the slope of one, so this is an example. If the slope of one line were 2 over 3, the opposite reciprocal of 2 over 3 has to be negative 3 over 2. So one's positive, one's negative, and they're reciprocals of each other. Another example would be negative 2 and 1/2. Keep in mind 2 is the same thing as 2 over 1. So these are opposite reciprocals. Special things to consider. All vertical lines are parallel to each other. That makes sense. They both have undefined slope. They just keep going. They'll never touch. Parallel is also indicated with 2 little arrows on the lines. So that is how we indicate parallel. Horizontal lines are also parallel. Their slopes are equal. They're both equal to 0. Just different spots. And again, parallel lines are marked with little arrows on the lines. And vertical lines and horizontal lines are perpendicular to one another. Okay, so one has a slope of 0, the other has an undefined slope. So vertical, horizontal are perpendicular, right angle right in the middle. So what we're going to do today is we are going to take a look at different equations of lines to begin with and determine if they are parallel, perpendicular, or neither. So numerous ways that this can happen here. Slope-intercept form is probably the easiest way to determine the slope. And keep in mind, for an equation to be in slope-intercept form, y has to be isolated. So y equals mx plus b is slope-intercept form. The number next to the x is the slope. The number by itself is the y-intercept. So the slope of our first line is 3. The slope of this line is also 3. Since those two slopes are equal, the lines are parallel. Have same slope. We're justifying our answer. In the process of justifying your answer, make sure you also actually find the slopes. Okay, here we have the slope of 2, and we have a slope of negative 2. Now, in this case, we have a positive, we have a negative, but they are not reciprocals. 2 and 2 are not reciprocals. The reciprocal of 2 is 1 over 2. So they aren't the same, they aren't opposite reciprocals, so they are neither. Okay, they just intersect somewhere. Slopes not the same or opposite reciprocals. So since it's not the same slope or an opposite reciprocal slope, it is a neither. They are not going to be parallel or perpendicular. Okay, for letter C, here's our 2 lines. The top line, the slope of the top one is m equals negative 4. For the bottom one, I'm not sure yet. I have to isolate y so I know the slope of that line. So I'm going to add x to both sides. And I have 4y equals x plus 3. Divide both sides by 4. And those cancel. Y is equal to 1 over 4x plus 3 over 4. So the slope is equal to 1/4. So I have a slope of negative 4 and I have a slope of 1/4. So since the slope is 1/4, that is the reciprocal of 4. One is positive, the other is negative. So these are opposite reciprocals. So for letter C, separate that, they are perpendicular. Slopes are opposite reciprocals. And we got it. All right, next one. Y equals a number. This is a horizontal line. This x equals a number. That is a vertical line. A vertical and a horizontal line are perpendicular. And I think my justification is pretty solid here. One's horizontal, other's vertical. That's what we got going on. Next one, x equals 8. That is a vertical line. X equals -1 is also a vertical line. Since they're both vertical lines, they are parallel. And we got it. Now on your own, go ahead and try out A, B, and C. Okay. Hopefully you paused it and took a try on A, B, and C. Going over our solutions. For A, the first line, m is equal to 2 over 3. And the bottom one, m is equal to -3 over 2, number next to the x. Those are opposite reciprocals, so they are perpendicular. Okay, next one, top one, y is isolated. M is equal to -3. Bottom one, I have to isolate the y so that I can see what m is. So I got to subtract 6x from both sides. And I have 2y equals -6x plus 9. Divide both sides by 2. And y is equal to -3x plus 9 over 2. Leave it as a fraction. So slope is -3. So the slopes are both equal to -3, therefore the lines are parallel. Same slopes. Okay? And our next one. We have y equals 3, that is horizontal. X equals 3 is vertical. So we have a horizontal line and a vertical line, they are perpendicular. All right. For our next one, determine which of these lines are parallel. And for us to do that, I'm told that they pass through some given points. So I need to figure out the slope of line 1, slope of line 2, slope of line 3. So I got to do the slope formula 3 times to figure this out. So I'm going to do line 1 first. M equals, I'm just going to write down my work over here. y2 minus y1. We've done this a lot, so I'm going to cruise through it. 1 minus 3. Over 5 minus -2. All right, 1 minus 3 is, readjust here a little bit, -2. Minus a negative, change to a positive, -2 over 7. So m is equal to -2 over 7. Next line, m equals 7 minus 9 over -3 minus 4. All right, 7 minus 9 is -2. -3 minus 4 is -7. -2 over -7 changes to positive 2/7, so m is equal to 2 over 7. Those are not parallel. One's negative, one's positive. Last one, 4 minus 6 over 7 minus 0, and 4 minus 6 is -2. 7 minus 0 is 7, so we have -2/7 for the bottom line. So the bottom one and the top one have the same slope, so line 1 is parallel to line 3. Okay, so you might have to do something where you have to calculate the slopes using the slope formulas as well. All right, I am going to cut it off here again for part 1. Okay, and we will come back with part 2 on how to write the equations of parallel and perpendicular lines. Have a great rest of the day.